Hey, Vlad here, devinsideyou.com. Welcome to another video. In the Curry-Howard-Lambach isomorphism video, we started the famous conversation about making the invalid state unrepresentable. And in the previous two videos, we talked about error handling and the applicative style. Today, we're going to continue the make all the things type safe conversation with a library called Refined. Let's get right to it. As in most of my videos, I'm in an Ubuntu 18.04 virtual machine and I'm running it on Windows, and the virtual desktop feature gives me shortcuts so that I can easily switch between Windows like this and my Ubuntu VM again, like that. Let's jump straight into code this time. So I'm just going to open my terminal and I'm going to go into my dev folder, which is currently empty. And I'm going to use the same template as we're always using, which is in dev inside use Scala CG8. And I'm going to call it, as always, playground. So I'm just going to ask my shell to open the Visual Studio Code right after it's done. So I'm just going to call it playground, and it's going to become dev inside you, and the package is going to be dev inside you, like this. There we go. Now Visual Studio Code is going to open, and as in most of my videos, you know that this is a template that I'm using for my actual project. For when I'm recording videos, I'm going to go and change a couple of things. Basically, I'm just going to go into the build, and I'm going to comment out these two flags. This should be enough. And also, since I want to minimize the amount of time I re-import the project, I'm going to add the dependency on refined right away. So it's going to be eu.template, and it's going to be called refined, and we're going to use the latest version, which is 0.9.10. All right, this should be enough. Let's now go and import the build. Also, let's start opening SPT. There we go. SPT. While this whole thing loads, I'm going to show you what we have. So we have Scala 2.13.1. It's SPT, what are we using? 137, which is the latest one. And we basically have a regular hello world main, as we have in most of my videos. All right, so now we can just run the project and we should see our regular hello world as always. All right, let's talk. What is Refined? Refined is a port of a Haskell library with exactly the same name. And what does it do? Well, it basically allows you to constrain or to refine your types even further than they are by default by attaching a predicate to them. For instance, it's very typical to want an integer to only be positive. So you take an integer and you refine it with a predicate greater than 0. Now, refined has been around since 2015, and so what we're going to do is we're going to go through the typical examples of how to do this manually without refined. It should take only a couple of minutes, so let me go and just create a couple of helpers. I'm going to have green here. I'm just going to take any and produce a string, and it's just going to do a console dot green plus input plus console dot reset. All right, and I'm going to have exactly the same thing, and I'm going to call it red as well. Red and whoops, red like this. There we go. So the way you would typically do it is basically there are two ways. So let's go and have final case class positive int, and it's going to take in a value, which is just an integer. Okay, and you just want to use the require function from the standard library, which takes in a requirement, which is a predicate, right? Value should be greater than 0, and it also takes a message, and this is where we're going to use red. I'm just going to say, that value, value was supposed to be greater 0, but it wasn't set phase like this. VS Code also completes the parens. All right, so now we can go and we can print out a positive int of 5, and it looks good, but we can go and do -5, and it doesn't, not ideal because exceptions, and also it doesn't compose that well. So for example, if we were to go and we were to copy this thing, by the way, let me comment this one out so that it looks normal. I'm going to paste that over here, and I'm going to call this one, for example, greater 10, and then I would need to put a 10 here like this, like that. Okay, so now if you wanted to do something like positive, and we couldn't do greater 10 and put a 20 in here, right? Even though greater 10 is clearly a positive thing, to the type system, these are two different things. Okay, now obviously we could go ahead and do the positive int and then wrap it, greater come on, greater 10 and pass it the -20, and then we need to extract the value out, right? It's inconvenient, but it's possible. Obviously, with a positive number, it would work. All right, there we go. A much better way is to use a thing called smart constructors. Let me go and just comment this whole thing out so that I can keep reusing the same names. Okay, so basically we have our final case class, positive int, and we're going to have a value which is an integer. And by the way, in this case we can extend any val. Let me actually show this to you. I kind of forgot to show this to you. So if we have this and we try to extend any val, extends any val like this, then it's not going to compile. It says this statement is not allowed in value classes. All right, so let's comment this out. But over here it's totally fine to have it. All right, so we just need to spell it correctly, any val, like this. All right, and then you would go and have an object, positive int, and it would have the smart constructor, right? So it's going to extend the function, which is optional, but let's do this. String positive int. All right, and we're just going to go and say final override, which is also optional. Def apply, and it's going to take in the value, and it's going to produce this either string or a pi. Oh, come on, pi tab. There we go, positive int. All right, so what you would do is you would say value greater than 0, that produce a right with a new positive int value, and then otherwise produce a left, and we're going to do the same thing as before. So I'm just going to go and paste it like that. There we go. Okay, like this. There we go, and now we can go and print out in the positive int of 5 and of -5, and now we don't have exceptions. We have the left or right. Now it's very important that you don't forget to go and make your constructor private, right? Because you can still go and do something like that, like this. All right, but if you go and make it private like this, then it's not going to work out. Also, the other thing that you need to be careful of is the copy method. So if we go and do something like positive int of 5, but then you can map it, right? So it's an either, we can map it, and if everything, even though everything went well, we can still call copy, and we can set a value to something that is negative, right? And now we're going to have a right with a positive int, which doesn't actually contain a positive hint. So what you can do is you can go over here and you can just define a copy method which will take in the new value, but it will use the old value as a default. The shadowing rules will allow us to do this, and we just need to produce another string positive int. It's totally fine to change the return type of the either, so we can just go over here and we can just call the positive int smart constructor, right? Like this. And now in this case it will actually do the correct thing. Okay, and in fact, in this case, we should probably go and use a flat map like this, right? So now we have, all the constraints are still fine now. By the way, I was kind of curious when I was preparing this video. Remember the videos about monocle and quick lens? I'm just going to go to our build and add them real quick. I'm going to go over here. I already have them prepared. So this is monocle and this is quick lens. Yes, please import the changes. Okay, so because I want to show you that the lenses, they can go in and they're basically copying they're basically calling the copy method, and therefore what I want to show you is that if we go and import software ML quick lens like this, and we import monocle macros syntax lens like this. Where did my console go? Terminal. There we go. All right. So now if we try to do the same thing, right? So we do positive int with a 5, and we map to modify underscore value, and we're going to do set to -2. It shouldn't compile, right? It's going to say, hey, type mismatch, I found an either, but I actually wanted a positive integer. And the same thing is not going to work with the other one, which is so this one was the quick lens, and this one is going to be just lens, and this is going to be set, and we should get exactly the same error message, right? Found either, but required a positive int. Okay, we're not gonna deal with lenses today. I was just kind of curious when I was preparing the video, so I went and tried it out, and I wanted to show it to you. All right, now as you can see, it's already better. Composition, it kind of got worse actually. So if we go and let me actually comment these out and put this over here. So I'm going to call this one like that. So I'm going to call it greater 10. I'm going to put a 1 over here and a 1 over here. All right, so if you wanted to do now print line greater 10, we're going to give it -20. We need to say map. We need to get the value out. We need to flat map to the positive end, like this. All right, so it works, but still not that ideal. All right, let me actually have both, one like this and one like that. Now, this is pretty much the best you can do without refine, but there's still pretty much a lot of room for error. There's a lot of room for forgetting to make the constructor private, forgetting to override the copy method, and you need to write all the tests for this. And it's super easy to copy paste something wrong and to forget like to have the error message in sync with your predicate. A lot of stuff that can go wrong. So one of the things that Refine brings to the table is that it looks at this problem and says, like most of these problems are not very specific to your business, right? To your business logic. Like for example, integers being positive or strings not being empty. So one of the things that it does for you, it goes and defines all of these predicates for you and tests them and make sure that they're all fine. And if it doesn't, then it allows you to compose your own, by basically composing the existing ones. We're going to see examples a bit later, and you can create your own, or you can go ahead and completely create your own from scratch without composing the existing ones. I'm going to show you an example of this a bit later in the video as well. All right, so let's start playing with Refined. We're going to go and comment everything out. You know what? I might even throw everything out. I don't think that we will need anything. Maybe we'll need the green and the red. Okay. Now, one of the problems that you will have when you're going to start playing with Refined is that there is a lot of macros and there's a lot of implicits, and therefore you might end up having quite a lot of import. They didn't want to put everything into one namespace just so that you don't have like all of the implicits in one scope, just so that it helps compilation a little bit. One of the other things that we will do before we start is we're going to add cats. This is not necessary. This is completely optional, but it will help me to do a couple of things. I also prefer to sort things by name basically. And also, as I already mentioned, we're not actually going to use the lenses, right? So we're going to use Refine and we're going to use cats, but you absolutely don't need to use cats, right? I will point out why, why I want to use cats, all right? So one of the first things, in fact, that we're going to do is we're going to go and we're going to import the cats implicits like this. And we're also going to import eu.timepit.refined underscore, and we're also going to import eu.timepit.refined numeric. All right, so inside of this one we're going to have the predicates for the numeric things, like positive integers and all of the positive, non-negative, min, max, and all of these things. And over here we're going to have the helpers to actually get the basically we're going to have like constructors to put the regular types into the refinement. All right, so one of the first things that we're going to do is we're just going to go on print line. And we're going to say refine v, which stands for refine value or refine a value class, which comes from this import over here. Okay, and we're going to give it a 5 like this. All right. Now, if we save this, it's going to say that it couldn't find an implicit value for parameter validate, right? So this is a type class inside of refined, which is used for validation. Now, in this case, it can't find it because it just doesn't know all the types, right? So it doesn't even know what your predicate is, right? So the predicate that we want to use is we want to use the same one as I have just been using, and it is called positive, and it's inside of numeric. Okay, positive means 1 or greater. All right, so we're going to say positive like this, and as we can see, the value is going to be right 5. So it's pretty much exactly as with the smart constructors. It's just that we don't have to go and implement them. Okay, so now we're going to do -5 like this, and we're going to see the error message, but it's not red. And this is exactly why I needed cats, because this whole left map thing on either only comes from cats. Okay, this is pretty much the only reason why I needed cats. Okay, because I wanted it to be, to look a little bit better. All right, now if we look at the type, if I go and press Control KI, we're going to see that the type is either a string or it's a refined int, and it's refined was the numeric predicate called positive. So we can go ahead and we can do good, either string or refined int or positive. We have the import, okay, and we can call exactly the same thing, refine v positive like this was a 5 like this. All right, now it says that it can't find refine. We can press Control dot with the latest version of Metals. We can just do that, and it imports this API as well. As I already mentioned, quite a few imports. Let me do this. Let me sort them. Prefer to sort my imports like this. All right, so these are the types. Let's also do bad. Let's go and do bad, and let's do -5, and we can pretty much remove these print lines because we can now just go and do print line good and print line bad, like this. The result should be exactly the same. And I forgot to do the left map thing. Left map red. There we go. Now, because we're being very specific with the type, we actually don't need to specify the predicate over here. However, at the bottom over here, we will need to specify it, not because the value is negative, but because we want to use left map, and it's just not going to find the exact type class that it needs. Okay, so I'm going to revert that like this, right? So the next thing that we're going to talk about is the infix notation. Every time you have a type that is parameterized with two other types, you can use the infix notation. So you can do int refined positive, right? So this is not specific to macros or refined or anything, right? You can do it with any, map or, anything that has two type parameters. So we're gonna go and do it over here as well, like this. There we go. Just be careful if you go too crazy with this, because in either it also takes only two type parameters, right? So it's either a string or this thing. So you can go and say, okay, so it's either string, either, and then on the right hand side you're going to want to write int refined positive, but that's not going to compile because of the associativity. So you actually need to go over here and to put this into parens. Notice that this is not a tuple, right? A tuple would have commas over here. Okay, so in fact, when I was preparing this video, I was kind of surprised. I didn't even know that you can use parens in your in your types, right? So basically, don't go crazy with the infix notation. Now, before we continue, I would like to point out, and this part usually gets people very excited, that there's a lot of macros there, right? So if you're only dealing with literals, which usually happens in tests, right? Because in your production code, usually your values, they come from the database to the web UI or back, right? So you don't actually see the literals. However, when you're writing your tests, you have literals there, and macros can actually help with that, right? So what you can do is, instead of doing that, you can just print line. And over here, we're going to say, instead of refine v, we're going to say mv, which stands for, macros value. Okay. And we can just say, same as before, positive, and pass in the 5. And now what it will do, it will not go through the either, right? So it looks at compile time at this literal. It knows that it is positive. Therefore, there is no need to wrap this into an either. And with the -1, what's going to happen is that it's just not going to compile, which is really, really awesome. And notice that it also doesn't compile with a pretty good message, right? It's exactly the same message. Predicate failed, -5 greater than 0. All right, just notice that if you forget the type over here, then the error message is going to be weird, right? It's going to say again that it just couldn't find this validate type class. All right, the instance. Okay, so I'm just going to do this, but I'm going to comment this out like this. All right, so just to point out again, so the type of this is int refined positive. Okay, so you can just go and say refined mv. Again, you don't need to specify the type, like this. Okay, what's wrong? Good is already defined. Let's call it good 1. Okay, and let's do the same thing with bad. This is the bad one. So this is the bad 1. Okay, I'm just showing you that you don't need to specify the type over here because it's already specified over here, and the error message is, oh, it's still not correct. That is interesting. All right. So we still need to specify the type over here to get the proper error message. All right, now let's comment this one out, and let me be extra clear that this only works for literals, right? So if you don't have a literal, right? Okay, like this, then if we go and try to use it over here, not a literal, like this, then it's going to say, okay, again, we need to specify the type, positive, like this, and now it will tell you compile time refinement only works with literals. So now you know. But as I already mentioned, it is super, super useful for your tests. So for example, if you have a final case class person has an age, which is an int refined positive like this, then you can just go and you can print out the person with the age of refine mv5 like this. All right, notice that I didn't have to specify the type because in this case everything was correct. But as always, if I make it wrong, the error message is going to be wrong. So you will be forced to do this to get the better error message like this. Now let me comment this out real quick. So if you wanted to get the value out, right? So you would do something like, actually, let me go and have the proper one like this. Okay, so let's say that you wanted to have the result 1 is int refined positive, which is a person of, oh, actually, I'm not going to use this one. Hold up. like that. Okay, well, actually it's correct now, so it can stay. Okay, person5.age, and if you wanted to get the actual int out of it, you would just say dot value. Okay, it's pretty much exactly the same as we did, manually. What's the problem? Type and match found in required positive. Oh yeah, I'm sorry, I actually forgot to refine that 5 like this. All right, there we go. Now, actually, I sort of forgot, because usually this is not what you do. So if you're dealing with macros, you can actually go ahead and let me clone one of these, and you can import auto. Okay, and auto will basically call this refine MV for you, and also it will call value for you. And also a bit later we will see it will help us with composition. So now what you can do is you can go and just over here you can just say 5, and over here the same thing. You can say 5. And also notice that if you have a -5, then the error message will be correct even though you didn't specify the type, right? So it says predicate failed, -5, right? So you didn't specify the type, everything is cool, right? So in your task, you don't need to go through this whole either thing like that. Now we're obviously playing only with a positive one, but refine defines quite a lot of predicates for you. And in fact, it goes even further, and it also defines types for you that are already refined, right? So basically this whole thing, so not just that, this whole thing is also defined in refine. So if we go over here, and basically there is a mirror import of types, right? So we don't only have the predicates, we also have the types, and they're named in such a way that their names don't collide. So for example, an int that is refined with positive is already inside there, and it is called pos int, like this. And now you also are not going to need this, like that, right? So it's either a string or a positive integer. Okay, so now everywhere over here we have positive integer, and so on. You also don't need to call dot value because you have this import like this, still compiles, still does exactly the same thing. And also what it does is it defines not only the type pos int, but it also has a, let's call it companion object for this type. It's not really a companion object, but it's an object with exactly the same name. So you can use it as a constructor, for example. So you can do pos int over here. Now this object also has other helper methods. So for example, we can go and say pos int dot from 5, right? So in case we're not dealing with literals, it will actually do this whole either thing for us, right? Left map, red. Okay. You can also do the unsafe version of this. So you can go and say, instead of from, you can say unsafe from, like this, and now it's not going to be an either, right? So it's basically, let me comment this one out, right? So it's basically going to go straight to the 5, or it's going to throw an exception, which nobody wants, but it's sometimes easier when you write the test, for example. And also because this is a numeric thing, then we also have the pos int min value, and we have the max value, like this. One last thing that you can do is you can pattern match, right? So you can use this pos int object to pattern match. So you can say case pos int value, then we're gonna print line good. I'm sorry, I wanted to say green, good. All right, and if we're gonna do the -5, and actually I wanted to do that as well. Print line red, bad, like this. Let me actually duplicate this line, bring it down like that, and do a -5 over here, right? Good or bad. So basically this object can be used for pattern matching. And also you can go and define your own. So for example, you can say type number equals int refined positive, and you can say object number, and you can say extends, and then you can go and do refined type ops dot numeric. I'm gonna do number and int, like this. All right, and now everywhere we're using pos int, I'm just gonna mark all of them. You can just go ahead and use number, right? So if we actually go and jump into it, I'm gonna revert this thing. So if I'm gonna jump into pos int, you're gonna see that this is defined exactly like this, right? So there's a type and there is also an object. It goes into this numeric thing. This numeric thing only goes and defines the min value and max value. I have no idea why it can't jump in there. It should be able to do that. Come on. Yeah, there we go. Refine ops. So yeah, so this particular one, it basically has the apply, it has the from, it has the unapply, it has the unsafe from, and as you can see, numeric basically just extends it with min value and with max value. All right, but you don't need to go so deeply. In fact, we're going to play around with this a bit later. For now, we can actually just comment it out. Now, this means that if you're not defining your own types, you can actually get away with less imports, right? Because you would basically just need, just this one, essentially, right? You don't need, to call the refined v because you're calling this object. You don't need to use the refined keywords. You don't need the API. You might still need this, right? So you might end up having like this one and this one. But in practice, you actually will have to define your own your own types very often by composing the existing one. In fact, we're going to do this in a bit. For now, let's just start playing with a different type. In fact, I should have jumped. So I want to show you another type, which is in net, like this, right? Net as in network. All right, so I'm going to go down and I'm going to go and use a port, right? So I'm going to say val port. I'm going to say this is a port number, and it's going to be -1337, and it's not going to compile because the port number cannot be negative. There we go. Left predicate or blah blah blah, failed. The port number can only be between basically 0 and 65535. All right, and if I do the the proper one, all right, so if I comment this one out, 1337, then it will be able to construct the port number for us. Okay, now if we actually jump into port number, just to see how it is defined, then we're going to see something weird. And in fact, I'm just going to go and copy this, and I'm going to bring it over here, and I'm going to say that this is going to be type our own number, and we're just going to paste it in like this. Okay, and now we can go and we can use it as our own. Let's call it our own port number. Our own port number. Now, if you look at this, which looks scary, and you might not be able to write something like this your own, but you will learn in just a couple of minutes. However, you should probably be able to read it anyway. You're gonna see, okay, this is a closed interval, and then it has some weird stuff, but there's a 0 and there's 65535. So it kind of makes sense. It's a port number. It's somewhere between 0 and 65535. Now, this whole thing works because Refined is based on another library called Shapeless, which pretty much pioneered type level programming, and it's pretty much a topic for another video. You can do insane things with Shapeless, and there are many libraries that are built on top of Shapeless, so you don't even see most of the times that they're built on Shapeless. Now, I'm not 100% sure about how to read this, but I'm pretty convinced that the W stands for witness. In fact, I believe we might even able to jump in there, right? Yes, if we jump in there, it actually doesn't even show W. It stands for witness. And I believe the way you read this is that there is a type that witnesses that the 0 is also a type, right? So you do W dot, and then you have your 0 in backticks, and you have a dot again, and you have the T. Okay, so basically what we need to understand is that the from is a type, right? So basically this is like that, and we can use from, right? I mean, they're being used in the type position. Okay, so you have 2, which is that thing. Okay, so they're basically just a little bit more, complicated types. Now, in the video about Curry-Howard-Lambach isomorphism, we learned about the type unit. I mean, I'm sure you knew it before, but you learned about the fact that it's called unit because there is only one instance of it. And unit is basically an anonymous singleton type, and you can also go ahead and define named singleton types. For example, you can go and say case object whatever, and its type is going to be, if I spell it correctly, it's going to be whatever dot type. Okay, so this is basically a named singleton type. Now what Shapeless allows you to do is it allows you to define singleton types based on literals. Okay, and this is also how they're called literal based singleton types. Now, what does it mean? Well, it means that you can go ahead and you can say, so I'm going to say that this is a 2, okay, and the type is going to be 2, okay, because this is a type. And if I go and try to do 1337, it's basically just not going to compile. It's going to say, hey, I found 1337, but I actually wanted the 65535. So maybe if we go and put it like here, the error message is going to be a little bit shorter, right? So it basically says, I found this, I wanted that. So it's only going to work if you actually go and put in this number, right? So I'm going to do that. I'm going to do this. Okay, now this technique has a lot of dark magic behind it, and also this is why that this is also the reason why there are so many corner cases, and you will constantly stumble on some issues with it. For example, I'm going to duplicate this line, and I'm just going to put a var over here. I can't use the same name. I'm just going to do this, right? So even though we're assigning exactly the same value, it's going to say assignment to non-variable var. It's kind of weird. However, there's some good news. If we jump into this W again, like this, we're going to see a reference to SIP 23. Now, SIP stands for Scala Improvement Proposals, and this is a proposal to basically integrate the literal-based singleton types directly into the Scala compiler. And in fact, this happened. This already happened. Most people don't know this, but it is already part of Scala 2.13. So I'm going to have a link down in the description to the SIP, to the SIP. But essentially what it allows you to do is it allows you to define the singleton types, which are based on literals, right? So literal-based singleton types without shapeless, right? So basically you can just go ahead and you can define over here that the type is 65535. Right? So we're using an integer as a type, and the compiler is a bit more happy about this, right? So basically everywhere we do this, we can do that, and over here we can just go and use the 0 over here. And now because they're so small, we can actually say that this is a closed interval from 0 to 65535. Like this. All right. Now there are many crazy things that you can do with literal based singleton types, but this is a topic for another video. So let me comment this out like this. Let me also remove all of that crap. By the way, if you remember the video about pattern matching, then you know that everything between the val and the equal sign is a pattern match. So what you can do is you can do 1337, and then you can say the type is 1337, and then you can say that the value is 1337, and this whole thing is actually valid code, right? So it basically says the value is 1337, the type is 1337, and it's only going to match if it's 1337. Okay, so as soon as I put, okay, let's change the type to 1338. Like this, it's just going to fail with a match exception, right? It's going to say match error 1338. I was expecting 1337, right? So this is just a pattern match, as most of you probably already know. Okay, just fun little tangent. Be aware that Bloop sometimes gets lost with this, and Scala FMT as well, and everything that is based on Scala Meta. I actually discovered a bug there and I filed it recently, so let's hope that it's going to get fixed by the time that you're watching this. Just so that we're on the same page, like this whole thing works for all literals except for functions, because the functional literals, they're not literally literals, right? They're just called like this, right? But you can go ahead and say val x, and you can say this is a string hello, like this. Okay, and now basically if this was a var, for example, you wouldn't be able to go and say world, right? It's going to say, hey, I wanted hello, you gave me world. Crazy thing, I know. It's kind of hard to get to wrap your head around this. Now let's talk about what closed is. Now obviously this is a predicate, but it is composed out of other predicates. So if we were to jump into refined, we would see that it's basically composed of something else, right? So what we're going to do is we're going to say predicate equals this thing. Okay, now if I were to jump in, and I already know how it looks like, so I'm going to go and say type predicate as well. I'm going to comment this out, and I'm going to say that this is actually greater equal 0, and it's less equal 65535, right? So exactly the same thing would happen if we were to jump in there. Let's see if Bloop can actually import it for us. Yes, it can. So it imported this one, booleans, right? So basically, let's do that. Let's go and do that. Let's go down. All right, so if I comment this out again and I do this and I jump in there, then we're going to see basically exactly the same thing, greater equal. So basically what I did in the preparation for this video, I just kept jumping inside and basically just using the substitution model of procedure evaluation, and I just did that, right? So it's not less than 0 and not greater 65535, right? Now all of these things, they are predicates, right? So they're equivalent to something like pos int, okay? So just all define like this is a boolean, this is a boolean, this is a numeric one, this is a numeric one, and so on, okay? Now one of the coolest things about Refined is that it allows you to compose things automatically. It doesn't always work, it's a bit constrained, but when it works, it's actually kind of cool, and it saves you a little bit of boilerplate. what we're going to do is we're going to go and we're going to parameterize this type, right? We're going to parameterize as was predicate like this, and therefore we're going to rename this one predicate 1. Okay, so this is one way to have the our own port number, right? So with this predicate, or you could also rewrite it and you can go and say type predicate 2. It's going to be greater equal 0, right? Which basically not less than 0 means it's greater equal than 0, and it's less equal 65535 like this. Okay, but also you can go ahead and you can say predicate 3, right? In fact, in this case, I'm going to go and do that. But also you can do greater -1, right? And notice that Bloop actually doesn't like it. Okay, so Bloop says that there is a mistake over here. You know, there is an error expected. Expected a closing brace but integer constant found. Okay, this is just a bug. It's going to be fixed at some point. As you can see, SBT is pretty happy with it. Okay, so the next thing that we're going to do is we're going to go and try to create ports. Okay, so we're going to say port 1 is going to be our own port number. In this case, we're going to use predicate 1. It's going to be 1337. Okay, and in this case, we're just going to do 2, and in this case, we're going to do 3. All right. Now let's go and see if we can do int1, which is a non-negative integer, right? So it's the same as pos_int, but it allows you to have the 0. Okay, so pretty much every port number is also a non-negative integer, so we should be able to do something like this, but we can't, right? It's not going to compile. It's going to take a bit to compile, but it's not going to compile. Basically, it says, hey, it's not going to work like this. Okay, let's go and try with the second one. So let me comment this one out. Let's do 2. Let's do 2 over here. Let's see. And it's also not going to compile. Okay, let's go and try with the third one. Let's go 3 over here. And let's go and do port 3 like this. And it's not going to compile. Let's comment this out. Let's go and do int4 like this, and we're going to do int refined greater equal 0, right? So this should be a non-negative integer. Okay, let's go and do port 1. All of a sudden it worked. Let's go and try this again with port 2. So let's do int5 port 2. In this case, it worked as well. And let's also do 6. And let's do port 3. And in this case, it's not gonna work. And I believe, like, I'm not 100% sure about this, but basically, I believe if your whole predicate is based on the same one, then it's gonna work, right? So if it's greater equals 0, it can compare greater equals 0 to greater equal 5 or something like this, right? But it can't, you know, compare greater equal to greater. Okay, so basically, you know, the typical example would be that you have x is int refined, let's say greater 5, okay, and we're going to do something like 6, okay, and now we're going to go over here and we're going to say that y is greater 4, okay, and now you should be able to do x because, you know, everything that is greater than 5 is also greater than 4. But as you have seen, it's very constrained. Sometimes it doesn't work, like in the case of non-negative integer, right, which could have been defined like this. In fact, if we jump inside, we should see that it is defined as, oh, come on, show me. Come on. No, oh, it probably doesn't work because Bloop is not happy about this one. Okay, so let's try to do that like this. Okay, maybe let's fix all the things like this, All right, so let's go and try this again. Come on, find it. Let's go into non-neg int again, like that, and let's try again. Okay, now it worked. So as you can see, it is defined as not negative. Okay, and negative is less than 0, right? So there's no you know, int refined or greater equals 0. Okay, so for some reason it's defined like this, and therefore this conversion didn't really work. But still, at least sometimes it works. So you could go ahead and do something like, let's call it 0a. Let's say that this is their int refined greater equal 0, right? And it's going to be 0. Okay, and let's go and do 0 0b, and it's going to be greater -1, right? So basically I'm just showing you what it boils down to. Okay, so 0a, this should not compile, right? Because over here we used greater equal, over here we used greater. Okay, so that's not going to work. Also, what's not going to work is if you do 0c. In fact, hold up, this is how I wanted it to be. I wanted the 0b be also 0 and show you that it actually compiles, but also go to 0c and show you that 0a is not going to work. Okay, so let's comment this out, and we can also go and do 0d, and we can do int refined greater -1, and we're going to use the 0b. Okay, because for this one we use the greater, it's going to work out. For these two we use the different ones. All right, now what you can also go and help the compiler out a little bit, you can go and say 0e, which is int refined with greater and then -1. You can go over here and you can say 0a, right? So usually it's not going to work, right? So this is exactly the same as with C, but you can go and say as instance of, which is dangerous, as we all know, 0c.type. Okay, so this thing is actually going to work, and we can do 0e like this. Not 0c.type. What did we want? We wanted 0e.type. Sorry, 0e.type. This one. This is what we want to cast it to. Okay, and in this case it actually worked with a 0 over here. Now you can also go through either. Okay, so you can go val 0 a b c d e f, and we're gonna have int refined greater -1, and we're gonna go and say that it's gonna be, for example, either catch only class cast. Come on, autocomplete it for me, please. Oh, come on. There we go, class cast exception, and we're going to have 0a as instance of 0c.type, and you can also do get or else 0, right? It's an either, so you can do a get or else. So this thing is basically a safer version of what we just did over here, and I wanted 0f. Okay, so the other thing is that you can do, which is probably a little bit shorter, 0g, which is int refined greater -1 equals basically just refine the value for me, right? Greater -1, and this is going to be the 0a dot value, and it's the same either get or else 0, right? So this is basically just a shorter version of this essentially. Okay, just never forget your basic principles. Always, you can always fall back to the typical refined v or refined mv in this case. Now this particular one breaks everything, so let's go and remove it. In fact, let's go remove all of these things. Right, there we go. Okay, so the next thing that we're going to do is we're going to show, I'm going to show you a couple of other types, how composition works. So for example, we could go and import the one for strings. There we go, like this. String, as you can see, as I mentioned in the beginning, quite a few imports. Okay, so we got the strings. So we could go and, for example, say type str equals string refined with, and we're going to have a bunch of them here. So for example, let's say that this string should be a valid integer, and it should also start with 1, again, literal based singleton type, and ends with 37, like this. Okay, so now if we go and say whatever one, it starts with like this. Okay, starts with 1, and we're going to have whatever, which is a string, which is 1337. And then it's going to work. Okay, but if I comment this out, and if I do whatever 2, and let's mess this up. So for example, let's say that this is not an integer like this, then it's just not going to compile, which is really, really awesome. And you can play around with this, but basically, let's comment this out. And let's do this one is actually, I don't need to rename it because I'm commenting it out anyway, right? So whatever. Okay, so let's say that it is an integer, but it just doesn't start with 1, right? Also not going to work, not going to compile. And let's comment this out. Let's also do, let's say that it starts with 1, but it actually doesn't end with 37. So let's say that this is a 5. Okay, it's also not going to compile. And you can do many crazy things. You can do regexes, you can do, all kinds of things. Now, what you need to know is that, as I already mentioned, that it's built on top of Shapeless. So if we import Shapeless, Shapeless. Okay, then there's also an alternative syntax of how we can write this. So now we can do type string equals, let me comment this one out. You can say that it's a string refined, and this is also a Boolean one. You can say all off, and over here you can just specify a bunch of them, but you don't specify them with a comma. You build a so-called heterogeneous list, right? So it comes from Shapeless. You can have a, usually lists are homogeneous. I still don't know how to spell it, right? So you can have a list which grows in size, but it is always growing with, integers inside or strings inside. And with heterogeneous lists, which are usually tuples, right? The problems that the tuples have is that they cannot grow. And, the shapeless thing gives you both, right? So you have a list with different types of elements. Basically, essentially every element remembers its own type. And, you can do crazy things with it, but as I already mentioned, this is a topic for another video, right? So we basically can say valid int. You construct it sort of similar way in how you would do a regular list. Basically, I can just copy this one. I can copy this one, put it over here, replace the ends with colon, which comes from Shapeless. And we need to build it the same way as you would do with a list. With a regular list, you would just say nil. With this one, you would just say h nil, like this. Okay, so this is exactly the same type. So for example, I can take this one, do that one, it's going to compile, and as soon as I ruin it like that, it's not going to compile, right? So this is exactly the same thing. Whatever you prefer, if you're familiar with Shapeless, and if you find this better. I believe this other one is actually a little bit shorter, right? So let's do string 1, and so string 1. String 2, let's comment this one out. Let's bring this one down like that. Okay, yeah. So this one is actually a bit shorter. So if I were you, I would probably use this one. But you do you. Now there's also any off and one off. And in fact, let's actually go into my browser, and I already have a link prepared. So basically, if you go to the GitHub page of Refined, and you just jump into provided predicates, right? So basically, I'm at the regular Refined page. Why am I not signed in? This link is going to be down in the description anyway, but basically it's GitHub F Thomas Refined. And if you go down, it actually has quite a good README. And over here, I basically clicked on provided predicates. Okay, so you have your booleans, true, false, not, and, or, and this is the one that we used. We use the all off, but there's also any off and one off. There's stuff for characters. There's stuff for collections. There's stuff for generic stuff like equality, a bunch of numeric stuff, a bunch of stuff for strings. These are the exciting ones, the URL, URI, or IPv4, regexes. So with regexes, one of them makes sure that the string that you're giving actually is a regex, and the other one is what you can use is that you basically say this string actually needs to match a regex. I believe if you actually go up, there will be example of this. So for example, over here, you're making sure that this thing is actually a regex, right? And it says it's not because there's an unclosed group, and there are other places where maybe not in the README, but basically if we go into something like if we go to port number, if we scroll down a little bit, then we might find some regexes, like over here, for example, right? You're basically saying that it matches this crazy regex, right? Cool, let's go back to our main. Now we're pretty much done with this video. I just want to point out a couple more things. As you have seen in the video about the Curry-Howard-Lambert isomorphism, it's totally a valid thing to construct a type which will be uninhabited, right? So the compiler will not prevent you from doing something like Boolean refined with an integer, right? You're not going to be able to construct anything of this type, and so it's not such a big deal. And if it's going to fail, it's going to fail at compile time anyway. So not such a big deal. The next thing that we're going to do is I'm going to show you how to define your own predicates without composing the existing ones. So the way you do it is you create it first, right? So you're just going to say this is going to be my favorite number, and it's going to be a favorite number dot type, and favorite number just going to be a object. We can also do case object. Doesn't really matter. Case object. Favorite number. Okay. So like this, so this is basically going to be your predicate. And now if you go and try something like print line or refine value, and you say favorite number like this, and you're going to put it in a 5, it's going to say that it doesn't know how to how to deal with this predicate because it needs an instance of this validate thing. So we need to go and we need to define it. So we say implicit val v1 v1, it's going to be validate of int and favorite number. Okay, and there's a companion object or an object that is called validate, and it has a couple of helper methods. One of them is, for example, from partial, right? So you're calling from partial, and it wants a partial function, right? So basically, if it throws an exception, then it didn't match. So we can do case 1337. You don't need to return anything, so we can just return a unit, okay? And we can put a comma over here. We're gonna give it a name. We're gonna say that is favorite number. And the predicate is going to be, the object that we have over there, right? The favorite number, okay? Like this. So now it's in there. Now it went ahead and matched it. And if you do a -5 over here, by the way, I did a 1337. So let's do 1337 over here, and let's do 1338 over here. Okay, so the first one is going to work. The second one is not going to work, right? It's going to be, okay, let's also do, the typical left map red. So basically it's going to say, I matched 1337, and over here it says is favorite number predicate failed, and it shows you 1338. I have no idea why it does that. It didn't do that with the regular ones. Maybe I'm doing something wrong. I'm not 100% experienced was refined, so maybe there's a better way to remove this thing. Another thing that you can do is you can go and let me actually clone this line, bring it down like this. Let me comment this one out, and I'm gonna do v2 over here. And what you can do is you can go validate dot and okay, Bloop is not happy. What did you just do? Okay, so auto completion is gone. Okay, so you can also do from predicate. Okay, and then you're gonna give it the predicate, which is the if it's 1337. Okay, and then you have the show expression where basically the number that was put in, like 1338 for example, was put in, and you can do something like n is not my favorite number. Okay, and the last one is the same as before. Favorite what file attribute view? How did you do that? Okay, so it's not validated, it's validate. All right. There we go. Okay, so now the error message looks different, but you also define it was a predicate instead of was a partial function. Okay, but now it says predicate failed. 1338 is not my favorite number, right? So it basically shows you exactly the same thing. One note about this is that when you start defining them, it will be inferred by default. So if I throw this out, it thinks right away that you actually want this one. Okay, even though I didn't specify that I wanted the favorite number. Another thing to know about Refined, actually, let's go back there, is that there is a ton of integration with other libraries. Where is it actually? Maybe community. Yeah. So basically, it has a bunch of internal models, right? So it has a bunch of integrations, of its own, right? So they're sort of like, the officially supported ones, and there are a bunch of others. There's integration with Monaco, with Postgres, with Pure Config, was a whole thing, like so many of them. In fact, what we're going to do is we're going to play around with cats, right? So we're basically going to go and do this one. I'm going to show the integration with cats. So we're going to go to our build, and we're going to do a comma here, do that. How did this thing happen? Like this, and actually sort it like that, comma here. And yes, please, let's go and import the changes. Okay, so what we're going to do is we're going to go and not here. We're going to go and import. Let me actually clone one of these. Right. So we're going to import cats like this. All right, and Bloop is going to be ready soon, and this line is not going to be red like this. All right, so let's go down. Okay, so now that we have this thing, let's actually remove that one. I actually don't really need it like this. Okay, so what you can do is you can do type 1 to 10. It's going to be int refined with an interval which is closed from 1 to 10. Okay, and we're going to say object 1 to 10 is basically the same thing, right? So you're going to say extends refine type ops. Okay, 1 to 10 int, right? So this is the same as before, but now we can also go and say with cats refined type ops syntax, right? So the cats refined integration basically it defines all the instances, for your refined classes, right? So if there is a monoid for an integer, then there is also a monoid for a positive integer, and so on and so on. But it also does this thing, which basically allows you to use validated instead of either, right? So you can go over here and you can say print line 1 to 10, right? So usually you would say from 5, right? And you would say from -5, and you would do left map red. Okay, but you can actually also go ahead now and do validated neck, for example, right? And now over here we need to do that because it's going to be a neck on the left, right? We have seen in the previous video how to deal with this thing. Validated neck is not a member. It's not validated. It's validate. Just kind of used to type that. Okay. So also, if you already have, right? So as you can see, you know, this is a chain now, and this whole thing is invalid instead of either, right? Also, if you're doing this for types that are not your own, you would actually need to go and add yet another import, and that would be cat's syntax. Cat's syntax, like this. All right, like that. Now we can go down and we can do something like, whoops. Basically, let's take that. Let's bring it down. Instead of 1 to 10, we're going to use pause int. Right, the pause int is already defined inside of Refine. Okay, so we can do something like this. It should work exactly the same. If you prefer the null for some reason, which is older, you shouldn't prefer it, but you know, you can still do null like this and null like this. And also one thing to note that it also has validate. However, validate behind the scenes also uses a null. Okay, so if you really for some reason wanted a validate, which is, you know, backed, you know, where the error message is just one and not an entire list, I don't know why you would want something like this, but you could. So basically you can just do, you know, the typical thing over here, to validated, right? This is the typical cats. Basically, you can just convert it and converting an either into a validated. And now, as you can see over here, this is not a chain. This is not a non-empty list. This is not a non-empty chain. Blah blah blah. None of that, right? So this is just a regular error message. Next thing I'm going to show you is how this auto import is helping you when you're basically when you're integrating Refined into an already existing code base, where you have, you know, some of your types are already refined and some of them are not. So if you do something like sum1, we have x is a positive integer and y is also a positive integer, then you know you want to sum them, but the result might not be a positive integer. So this is an either string or positive integer like this. So you can go ahead and do pause int from x plus y like this, right? Or you can go ahead and do this thing, which is shorter, right? So you can do refine v, right? So basically what I'm showing you is that you don't need to go and say, you know, dot value over here, right? Because you have this auto import. Okay, so if one of your types is not refined yet, it's not a problem. So if this is an integer, it's still gonna work just fine. If you use an integer on the other side, right? So this is a pause int, and this is just an int, it still works like a charm. Now, since we had videos about validation in the previous video and Refined pretty much fits into it like a glove, I actually want to go and create another file. I'm going to call it person.scala, and I'm going to show you a typical validation example, you know, how much easier it is, you know, with something like Refined. We're going to need a lot of imports. In fact, I'm going to go and copy a bunch of these. In fact, I'm going to go and copy these. Okay, so we're gonna need the implicits. We're also gonna need the data, and we're not gonna need the refined. We're gonna need the API. We're not gonna need the auto. We're gonna need the boolean. We're gonna need the cats. We're gonna need the cat syntax. We're also gonna go and use collection, and we're not going to need numeric in this case. However, we're going to need the numeric types. We're not going to need the net. Okay, so I believe that these are all the imports that we're going to need, which basically also shows you that most of the code is not something that you have to write. It's something that is already written. Okay, so basically we're going to have a final case class person, which is going to have a name, which is going to be of type name, and age, which is going to be of type age. Now, both of these types are going to be defined inside of the companion object, right? And therefore, we're going to need to import person like this. All right. So over here, we're going to go and we're going to have type name, which is going to be a bit complicated, and we're also going to have type age. The age is going to be simple. It's just basically a non-negative integer, right? So you can have, 0 years. Actually, let's do nothing for now because I just want to see that it compiles. Okay. So the type for name is actually going to be a bit more complicated. So we're going to go into string and we're going to say that it's going to be refined with. So I don't want it to be empty, and also I want it to be trimmed, right? So I don't want the white spaces. Okay. And therefore we're going to create also an object over here. All right, so all of this is pretty much optional, right? So it's just helper methods that will allow us to have, a nice API. Okay, same as before with cats. I don't want to type this thing. Come on, help me. There we go. Was this thing. Okay, and for age we can actually go and use the same object that is defined and refined. Okay, so I can jump in. This is this object, refine type ops numeric, same as before. Okay, and now that we have these helpers, so what I usually do is I pretend that I have like a form, and in that form I'm gonna have like a raw version of the person. So it's gonna be a case class which is just gonna gather a bunch of strings or ints, right? So I'm gonna have a final case class raw over here, just going to take a name which is a string, age which is an int. Okay, so this is what's going to happen in my form, and then basically I'm just going to have a function called apply over here where a raw comes in but a validated neck with a string or person comes out. Okay, basically the classic validation, same as we did before, okay, in the previous videos. Okay, so now I can just go to name, which is this object over here. As you have seen, I can do validate neck, I can give it the name. Right, so we're basically constructing a tuple over here, age, validate neck, raw dot age. Okay, I'm gonna do map and we're just gonna pass it the apply. The apply is the construction of this person. Okay, so this is the entire code, 32 lines. Most of them are actually imports. As you can see, a bunch of lines for the imports. Okay, so yeah, but this is basically the entire thing. Just that, a couple of lines. You don't need to do this whole validation logic yourself. You don't need to do, if it's empty, then produce the left, or the invalid one or the valid one. Okay, so now let's go into main and play around with this a little bit. Okay, so we can go to raw. Over here we can say val raw is person. In fact, let's also have that. Okay, so we're gonna have raw, which is gonna be a person.raw. So we're gonna create a person.raw with a name which is good, and with age which is 32, like this, right? So we can go and we can print line raw like this. Okay, it probably says that person is already defined. What does it say? Type raw is not a member of object main person. Exactly. So let's go to, come on, where is it? Person. There we go. It's this one. Total collision. So let's comment these ones out. All right, there we go. Probably need more space over here, like this. Okay, so we basically need to only look at the stuff that is between the lines over here. Okay, and now we can go and say val person, which is a validated neck of string and person. I probably will need an import for this actually. Yeah, let's go and do data. All right, so we're gonna have that, and now you can just construct a person by giving it the raw person. You don't have to do this whole raw thing, right? So you can just go straight into the function with the string and the the int in this case. Okay, so now we're gonna have this person. Let's also print out print line person. All right, in this case everything worked just fine. But if we go and do something like, so I'm going to replace it with bad, I'm going to do a space over here, right? So now it's not trimmed anymore. Now it's not trimmed. Now the validation is going to break, and we see our error message. Let's also do the negative 32 for the age, and you're going to see that we have both the error messages, right? So this is a chain with this error message, and this is also why I use the color, because you see this white comma, and both of the predicates failed. We can do let's comment this one out. Let's do just space over here like this. We should see the other error message, right? Something failed. We can also do empty like this. Something failed. Come on. All right, and I actually haven't tried this, but if you want it, and just do person name equals good, and age equals 32. So we're not constructing raw, we're constructing the actual person, right? But because we're using literals, because I'm imagining that we're in the test, it will be checked at compile time, right? So as soon as I have a space over here, it's not going to compile. It's going to say that this is a there we go, right? This is the right predicate failed, which is really, really awesome. Let's go and fix it real quick. All right, if you want to do some more research, I'm going to have a couple of links down in the description to things like liquid types. And also don't forget that the link to the SIP23 is also going to be in the description. There's a lot of cool stuff in there, so make sure you go check it out. And for now, as always, it's been Vlad, devinside.com. Don't forget to like this video if you did, subscribe if you want to improve the developer inside you, and if you find my videos valuable, consider supporting me on Patreon. But most importantly, take care.